Hello, SpaceX. Hi, John Chabot here, and today I'm applying to the Fluid Systems Software Engineering position. I'm a recent graduate of Miami University's Master of Science in Mechanical Engineering with a focus on mathematical models and simulation. With that being said, my thesis work as well as the majority of my side projects focus in the fluid simulation subdomain of reduced order models. And unfortunately, these don't produce quite the showy flow reconstructions like your more traditional direct numerical simulation, large A simulation, or RAND model. There are plenty of figures and movies I could show you, but they typically require a fairly lengthy and a fairly dry technical presentation to really convey what's being demonstrated. So instead, I decided to take a more creative approach and produce a simulation of SpaceX's future launch capabilities using this fully autonomous system described in the job description. So I'll go ahead and let that video roll, and I'll be back in a few minutes. Thank you.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
hopefully the ending wasn't too dramatic, especially on the music end, but it was hard to resist. This was the first video I've actually put together, so I had a little fun with Windows Movie Maker creating this video. But anyways, I would like to actually take some time to quickly go over some brief aspects of my thesis work, um, as well as the included presentation I've submitted with this application. So the 1 minute elevator speech of my thesis work is we developed a novel and objective procedure of validating some simulation based on some experimentally collected data such as PIV. We use some theory from machine learning, also known as statistical learning, as well as some aspects of dynamical systems to try to characterize how the dynamics evolve both in the experimental data and in the real data. So first show some animations of the clustering algorithms, which are explained a little bit if you take the time to go look through my presentation I've attached. And then next we show a representation of a model in phase space after we use a technique known as principal component analysis. And then finally we show reconstruction at the end showing the vorticity. So again, thank you for your consideration. Obviously the video I showed you shouldn't be taken very seriously, but do know that I do take this application very seriously. I believe in the mission at SpaceX. It's very clear cut, and I look forward to potentially working with people in a similar mindset. So I'd like to again encourage you to take a look through my thesis presentation to kind of get a feel of the work I did in fluid simulations. But at this point, I'll go ahead and wrap up the video. But to trail off the end, I'll go ahead and include a in the making bloopers reel of the previous segment. So again, thank you for your consideration, and I look forward to hearing from you.